Welcome to Key Skill 5. I hope you have a sudden burst of energy like I do because we're gonna get this finished now. We're gonna start looking a little bit about how calculus ties into this question. We're gonna be studying something called the quotient rule. Now the formula for the quotient rule will be in your formula booklet, so you need to have a little look in there and find it. If you can memorize it, great, but if not, it is there for you. I noticed that when I was combing through the questions, that the longer, maybe the 8-mark questions on algebraic fractions that have an A, B, and a C, tie in with this calculus theme. So the part A might look like this: simplify as much as possible, and they've given you an algebraic fraction. I personally picked one from Key Skill 1, but it could be using any of the skills that we've learned. It could be with cancelling down, Key Skill 1. It could be with multiplying, dividing, Key Skill 2, or adding or subtracting, Key Skill 3. So you're going to do that algebra part first. And then it will say something like this: hence find f dash x and f of x, f dash 3. So in this situation, they would have told you here, this would be your f of x. This would be your function. Now, if we whiz all the way back to Key Skill 1, we can see that the simplified version, 1, 2, 3, gosh, we've done a lot of work today. The simplified version of this fraction was 2x minus 1 divided by x plus 1. When you start the differentiation, you want to use the simplified version. If you don't, it will still work, you'll still get the right answer, but you're going to waste a lot of time and energy and have really big equations. They tell you in the part A to do the simplification to help you. So don't ignore that when you get to the B or the C part of the question. Now, in order to differentiate this is a fraction. This is something you won't have seen before. You identify the numerator of the fraction as u, and always u, and the denominator or the bottom of the fraction as v. Okay, so u the top, v the bottom. What you need to do now is differentiate u. So again, you might need to refer back to the courses from ASMS on how to differentiate things, if that's a bit foggy now. I'm going to assume you know how to differentiate. So the power there is 1, 2 times 1 is 2, and that would be x1 minus 1, x0 would be nothing. Any numbers on their own differentiate to 0. So we can do something similar here. 1x would differentiate to 1, again, because when you subtract 1 from the power, x power 0 would be 1. So 1 times 1 is 1, x0 is 1. And any numbers, they disappear. So you should have now u dash, which is the differentiated version of u, v and v dash. You're going to put them all into this formula. The formula is v multiplied by u dash, subtract u multiplied by v dash, all divided by v squared. Now this formula can look pretty scary, pretty intimidating, but you just need to match up. For example, you just need to match up with what you've already done. So that's the u, so that's going to go in here. And it's u dash here. We'll put that in orange. We'll go here. We've got the right orange there. V, which we're going to have in this bright, or maybe not the bright green, in the purple. V you're going to use in 2 places, here and here. And the last one, the v dash, oh, I forgot my dash here, it's going to be there. We'll keep that in black. So before differentiation from the fraction, and these are the after differentiation. So let's substitute everything in. I'm going to leave myself quite a bit of space here. So I need to do, I think sometimes it's easier to remember it's this way, because it's v times with u dash. So this one goes first, and that's important. So the 2 gets times with the x plus 1. Then we put a big minus sign, and then we go the other way. These two together next. So the v dash, it's going to be 1 times by u, which is 2x minus 1. I've put them the other way around than I've written them in the formula just because I like my brackets to have the number here and the brackets there. But you could also put it, that one times 2, you could put it behind. It would be perfectly correct. Divided all by v squared. So I'm going to put here x plus 1 all squared. It's always exactly the same. So if you remember that when you start the fraction, you go this way, subtract this way. And on the bottom, it's always what the original bottom was, squared. As I mentioned before, generally speaking, when you're dealing with algebraic fractions, you don't multiply out the bottom. So I would leave that as x plus 1 all squared. You will, however, multiply out this. So that would be 2x plus 2 minus 2x minus minus would be plus 1. Wait. Simplifying down, 2x minus 2x will be nothing, and 2 plus 1 is 3. So final answer, 3 divided by x plus 1 all squared. And that will be our f dash x. That's our differentiated version of x. So for any fraction, and later on in the course we'll be doing more complicated fractions with e's and logs and causes and sines. But for the beginning, we're going to start with basic examples. So you identify your u and your v, and you differentiate them. Then you just substitute them correctly into the formula and multiply everything out. Now that will get you the marks for this, hence find f dash x. We've got f dash x, it's here. But to get the marks for f dash 3, you need to put into the f dash x equation 3. So if I start from here, if I want f dash 3, I'm going to copy this, but I'm going to change the x into 3. So I'm going to have, I feel like having red, I'm going to have 3 wherever I had x. So any x's are being replaced with 3. Now brackets should be the first thing I do. 3 plus 1 is 4. And 4 squared is 16. So that will be 3 over 16 as my final answer for f dash 3. And that's a wrap, folks. That is the quotient rule, how it comes in the exam when it's connected to the algebraic fractions questions. I hope that was super useful. The next course I'm thinking about doing will be all about exponent and logarithm functions. So stay posted for that. And I will see you guys in the next one. Hope that your year has started really, really well. And bye for now.